I'm going to do building RESTful web services APIs. All right, so what are RESTful web services? It stands for Representational State Transfer. It's an architectural style, so it's not some like product or protocol or something like that. It's a set of constraints, so it's not just the Wild West. You have some guidelines for how you're supposed to actually do stuff. And it's a method of accessing and manipulating the text representations of resources the same way every time. In general, all conversations about RESTful web services are in the context of stateless. So maintaining state across HTTP calls is a little bit funny, so they really just don't want you to do it because it doesn't work out very well from a scalability perspective, and it's difficult if you're a client consumer of it to know, can I make this call now? No, you can't, because it's not got the right state. So stateless is the way forward for RESTful web services. So there's a couple of key architectural goals conceptually. So we want to be accessible from any environment. So if you have a client that's a browser or a client that's a thin client or some other web service somewhere, it shouldn't matter who is trying to talk to your web service. It should all work everywhere, every time. We want our interfaces to be simple and uniform so people understand when they look at what you've given them, this is how I'm supposed to use this thing that you've just handed me. So we don't want huge WSDLs floating around that are like 20 megabytes that no one can ever possibly read as a human. We want things to be simple and easily understood. And performance and scalability. So there's not a whole lot of usefulness in a web service if I call it and it takes 2 minutes to return me data, or if 10 people call it at the same time, it falls over. That wouldn't be good. It wouldn't serve your purposes. So we have some level of performance and scalability that really has to get met when you're dealing with web services. And here's just a quick list of a couple of standards bits that are used in most, if not all, RESTful implementations, and certainly in our implementation. So that's the URI standard, the HTTP standard, and the JSON standard. So from our perspective, why do we want to use REST? It is simple to learn, build, and use. So we're just using URLs and HTTP verbs to actually do stuff. It's simple to write and document, so you can make your API pretty straightforward. And whenever you're giving that API out to someone, you're going to have to provide some kind of documentation so that they know how to call it. So it's simple to document because it's just URIs and HTTP verbs. It is completely open, so you can reach more clients. There's less overhead inherent in a RESTful design just because of that statelessness. Less duplication, so we should be able to just have our web service exist and people can call it, so they don't have to jump around to different silos of APIs that you're providing. You can put out one API that does everything. And more standardized, so we are using standards inside of REST, so we want to leverage those as much as possible. And a really, really big bullet point here, maybe I should have increased the font, is that it is testable. So I do have a session later on about load testing, and it's very much this bullet point. So if you have all of your logic bottled up inside of an application and it's stateful, testing that, you actually have to interact with UI, or you can factor your code such that you can write unit tests or whatever. But when you have RESTful web service APIs, they're already factored that way, right? Like you write a test from the outside and it doesn't interact with UI, and it just goes and it hammers away at your functionality, and it either returns the right data or it doesn't return the right data. And writing tests is super, super easy. And then keeping your application running the same way over time is a lot easier, because your tests, they run, they tell you, yeah, that was a good plan. No, that wasn't a good plan. You need to fix this. So testable is a really, really, really big part of why we think RESTful web service APIs are the way forward. And a huge amount of the public API sphere is implemented as RESTful web services. So 70%, something like that. I'm not sure where that statistic came from, but it seems pretty reasonable based on anecdotal evidence that most people are offering up their APIs as RESTful web services. Here's our answer to how do we actually do that. So Harmony Core is a framework of patterns, practices, codegen templates, and libraries used to create RESTful web services that expose synergy data and logic. So what are the framework of patterns and practices? That is, they're guidelines. They're not hard and fast rules. They're not there to prevent you from doing stuff. They're there to provide you with some guide rails so that you don't get overwhelmed by the amount of choices that are available to you. If the entire world were the only constraints, then you'd go and you'd sit there and say, well, I could go this way, or I could go this way, or I could go that way. So we bring it into a set that we think actually works for you guys in this room and say, these are our patterns and practices that have worked elsewhere, and we think if you follow this, you'll be more successful. Why did we actually go through all of the effort to make it? APIs make you guys sticky. So when your customers are sticky to you, you're sticky to us. So we like sticky APIs because we want you to stick around. So that's a big plus. Integrating deeply with other software gives your customers better experiences. So Harmony Core and Web Services APIs make it possible for the other software that your customers use to talk to you. Or if your customers are large enterprise users, for them to integrate into the rest of their workflow more deeply with your product in particular. So the deeper entangled with you they are, again, the stickier they are and the happier they are. So when things work smoothly from front to back, everybody wins. Or at least, everyone making products that get used wins. UIs change like the wind. It wasn't all that long ago that Toolkit was the amazing way forward and this is how you make UIs, and then all of a sudden it was WinForms or VB6 or something like that, and then WPF came along and everything in the web front was already there, like moving forward at breakneck pace. Every 6 months there's another JavaScript framework somewhere that says this is the new way to do UIs on the web. So those are going to keep changing constantly, and web services kind of insulate you guys from that. So if your backend doesn't have to make any adaptation to whatever the framework du jour is, then that's good for you, because changing your backend services to fit some UI, whatever toolkit thing, that wouldn't be a productive use of your time. So web services insulate you from UIs getting changed constantly. We also needed a single coherent answer to the question of how. So we've had a lot of products in the past that have answered part of this question, and we needed to unify all of them into one answer. So XF Server Plus, XF Server, Harmony Core, and Symfony Framework in general. And we also needed a servicing model that allowed us to evolve and adapt. So Harmony Core does not ship in the box. So when Chris sends me an email and says something is broken, I don't have to wait and ship the fix to him using an SDE installer. I just go fix it, run all of the tests, and validate it against what customer subsets that I have not broken anything, and then I ship it out to NuGet.org and tell Chris he can upgrade and he'll have his bug fix. So things can move a lot faster that way, and because of the way we do the testing for the product, it can move that fast without hopefully breaking anything. So what are the parts? We have built it out of a OData set of libraries. So most of that is provided for us by Microsoft and by the rest of the members that work on the OData standard. We are a entity framework core provider. So way back, I think 2007, maybe 2008, Synergex offered a entity framework 1.0 provider. And we pulled that because it didn't really mesh very well with non-relational data. And EF Core has, as one of their primary tenets, the idea that they should work with more than just SQL Server, which is refreshing for us as not SQL Server, that they would like to work with people other than that. So we wrote a EF Core provider. It's open source. It's part of Harmony Core, and it's how we support all of the operations that occur directly on top of data. So routing conventions. When you work inside of REST and you're dealing with URIs and HTTP methods, someone has to come up with a convention that says, like, this is how we go from a URI to a piece of code or a piece of data or whatever. And a lot of those are provided in the box by either OData libraries that we use or by ASP.NET Core that we also sit on top of. But some of them are specific to Harmony Core. And I'll go into them a little bit more in depth later on, but just the idea that there are conventions around how do you go from a URI to a piece of code that's running. We also have bits and pieces for performing code isolation. So if you have code that cannot coexist with other code at the same time in the same process, we either offer ways of isolating that inside of your process, depending on what you're isolating. We can isolate it out of process and communicate with it not over a network, but over standard in, standard out to the process directly. Or we can isolate that code out to run somewhere else on a network share, or rather on a machine that is running somewhere else on your network. We are also built very, very, very heavily on top of CodeGen. Pretty much everything here runs through CodeGen. We have our binary bits, and then we have the parts that actually are customer specific. And generally speaking, those get code generated. So we have a significant dependency on CodeGen. And on top of .NET Core. So I don't know how many people are following the build announcements that happened yesterday. .NET Core is the new .NET framework, and it will become the new .NET framework officially in, I think, the first half of 2020. So it is going to be renamed .NET Framework 5. So it won't be called .NET Core anymore. Nice of them to keep changing the name on us. But it is the path forward. So it was fortunate for us that we took that dependency, and that is the direction that they are going now. So EF Core, this is how we provide access to data. So you can use the EF Core provider in code, or you can just use the EF Core provider plugged straight into our framework, and you don't have to actually write Synergy code in order to interact or to expose your data. You're just dealing with Synergy repository to define the data that you want to be able to expose, and you can put constraints on it and that sort of thing. But what I'm about to talk to is EF Core, the provider, and the things that it does internally. So when you are performing read operations on EF Core, it is handed a LINQ expression tree. So it's this big language integrated query thing that's provided from whoever is calling it. So if OData is the one that's calling it, so the framework, us, is calling it, that's who constructs that out of a URL. If you, the user, are using it as code, you could be using LINQ queries that are generated from C#, or you could be using LINQ queries that are generated from the helpers that we offer inside of Harmony Core. But they get translated from those trees into Synergy select objects or read, readS, and find statements. It depends on what query you hand us, what direction we're going to go down. So if it's a simple, we have a key and we're just reading from here to there, we're going to pick read, readS, find type statements where we can, because they are just a little bit faster. And if it's a complicated set of selection criteria, then we're going to transform that into a Synergy select statement and or object tree and run that instead. So that choice, that translation that I'm talking about, is cached and not recomputed each time. So if it sounds like what I just described would be slow because it's operating on this big tree and it's making decisions about what's the right way to do it, yeah, it's a little bit slow, which is why we don't do it every time you ask for it. We translate it once, and then it runs. And it uses sparse functionality where appropriate. So the Synergy select statement has sparse records. So when you're talking over access server, it is handy to not send back and forth large records, like a 64K record, for example, when you only wanted like 100 bytes of that record. So if you ask us, I only want these fields, we will only ask XF Server to give us those fields worth of data. And the where appropriate is because if you're not using XF Server, there's no reason to go through the hassle to say, like, only give me these byte ranges. So if the channels are not XF Server channels, we ignore the idea of sparse and we just read the whole record because it's not really transferring anywhere. There's no cost to it. And in fact, it's a little bit faster, just a tiny fraction of a % faster. So we just skip it. And our implementation for interacting with ISAM represents current best practices for data retrieval. Again, we try and shave off those microseconds on each transaction because we have to support the idea of like 1,000 concurrent connections. And so we have to shave off absolutely every little piece of something that we can shave off. So I haven't necessarily talked much in the past about how to do writes. So EF Core is, up to this point, my description probably sounds an awful lot like XFODBC or about our prior entity framework provider. But with both of those, we've strongly recommended that people not try and write data with them. And that is not the case with the EF Core provider. We're very pro writing data with it. It translates it directly into a store or write statement. You can re-implement that if you want to. So it's just a couple of classes that you inherit from and offer up as services, but you can rip out our guts in terms of how we write records. You can replace them with your implementations if you want to. It works with I/O hooks. So if you register I/O hooks and do the appropriate, again, inherit from a thing, replace it with your guts, you put in where it says, I'm trying to open this file name, what I/O hook do you want to register to go along with this? And then you offer up your I/O hook, and the I/O hooks work from there. Even in the case where the data layer is the one doing key generation, so if you're inserting a new record, you don't necessarily know what the key is until like you go look it up somewhere in the rest of your system to figure out what is the primary key of this record supposed to be. I don't know what the next customer in line is, so I need to go do something. So we offer customization there to allow you to go out and do that work, give us that key inside of the provider, and go onward from there. But the EF Core user itself, which is again you, but a different part of you, doesn't have to deal with that implementation detail of how do I come up with primary keys, because you've filled in that little bit of implementation and it just sort of works in a nice cohesive sort of way. In general, we have a lot of support for partial methods and partial classes throughout the Harmony Core framework. So Steve has talked about partial methods a lot in previous conference material, but just really quick, the idea of a partial method is something that we've declared in our code-generated code that you can replace or not replace. It's up to you. It's not inheritance, it's a compile time thing, so there's no cost associated with it. You're just saying, like, did I provide an implementation, or is there nothing there and so nothing gets run? We offer partial methods for validating your data. So when someone tries to write some record, you get a chance to look at that record and say, no, this is not valid. You can't possibly store this record. It's breaking whatever this set of rules are that you have in your logic, and it'll reject the transaction and kick it all right back out. And again, you can replace all of our I/O routines by extending classes and in the file I/O classes. So if you have custom stuff that you have to run on reads or writes, you can replace it with your stuff instead of ours. The big one here is that EF Core participates in transactions. So if you write 100 records, you modify 100 records, whatever, and you make it to record number 99, and it fails to write because someone changed it out from under you, or because the file is full, or because who knows what, we will roll everything back. So nothing happened. So your transaction either completes successfully and all the data is written, or nothing happens. So EF Core, as part of that writing, we're working on the idea that patch is potentially an important part of that, and we're trying to support patch directly inside of EF Core. So using a thing called a JSON patch document, you can supply essentially a set of instructions that says, I want to add, remove, replace, copy, move, or test something. And the provider has helper functions that are going to run those things for you inside the context of the transaction. And again, those will either succeed or fail as a whole. But it offers you a way to sort of reach inside of the transaction processor without having to actually go customize it for real. So it's just another extensibility point for you. So EF Core transactions, it's kind of a big deal. Right now, we offer read committed level transaction isolation. So there's a bunch of different layers or levels of transaction isolation, and we are at read committed. Generally speaking, Synergy, though it doesn't actually have transactions, could be thought of as read uncommitted, because as you guys are running code, you're writing records into the file, and anyone else who is reading from that file is going to see those changes reflected immediately. So inside of EF Core, those records are not changed for the rest of the world until the transaction is being finished. And if other people have not finished committing a transaction, your EF Core transaction will not see those until they are committed. So you're not seeing sort of this half-written data version of events. You're seeing only whole sections of the world that are consistent. We use very heavily optimistic concurrency based on GRFAs. So the G in RFA, although I don't know entirely how this G stands for this, is basically the CRC of the data that is your record. So we've hashed your record, we know what it was supposed to look like, and we also know where on disk your record is stored. So every record has the record file address that gets you straight to the record, and being a GRFA instead of just an RFA includes additionally the idea that this is what that data looks like. Here's the hash for that data so that I know no one has changed it. So if I supply a GRFA, I have a position and I have a point in time where I say, I know this should have looked this way. So GRFAs let us not actually lock anything in the file until just before we go to commit the transaction. So there's performance benefits for that, especially for things like XF Server. But in general, it prevents you from locking yourself out in these sort of large transactions. And this is actually sort of the secret sauce that makes our EF Core provider do write transactions as opposed to XFODBC and the prior entity framework provider where we said, don't write stuff, you'll lock yourself out. It uses pessimistic locking and you'll literally lock yourself out as you make your way through the transaction. This is why we don't lock ourselves out. Nothing is written to disk until you say save changes. So you've read a whole bunch of stuff in and you've made changes to those in memory, and there's not a EF Core provider dot store record. So you don't go after individual records and say write it to disk. You make changes to the environment and then you say, I would like to save those changes. And so it knows all of the things that you did in your transaction. It keeps track of those, and anything that got actually changed in that transaction gets persisted to disk. And if something fails, obviously nothing gets persisted to disk. So that's all tracked by the DB context internally in your code. So no leftovers after something fails. So specifics on how on earth are we making sure that nothing is left over when something fails. So here's the under the hood view of a Harmony Core file transaction. So you, the user, have called dbcontext.savechanges. So we're about to start actually like writing stuff to disk. So you've executed user logic and you've done a bunch of read operations. So we're going to be handed a list of, here are all of the things that have actually changed by the framework. And we are going to lock all of those records. So we're just going to take a manual lock on each one of those records all the way down the list, however many you have. And then we are going to create and lock new records, update all of the records, delete any records that are supposed to have been deleted, and then unlock all records. Ta-da, transaction is complete, right? So what happens when stuff goes wrong? So if stuff goes wrong while we are in the phase where we're just locking records that are going to be updated or deleted, we haven't written anything. We're just acquiring locks at this point. We've essentially failed and timed out trying to acquire a lock. Like that's the main failure that we're going to run into here. Someone is sitting on that record. We cannot proceed any farther. So unable to get a lock, response, throw an exception. We just unlock everything. Nothing bad has happened. We exit the transaction and you can either retry or do whatever it is that you need to do to mitigate that lock being stuck. Maybe we get a different GRFA. So we went to go lock a record and the GRFA is not the same. So someone changed it out from under you. So throw an exception. You, the user, you can catch that concurrency exception and you can decide, like, do I just want to rerun the transaction? Do I just want to change this particular record and try again? Or do I want to abort and kick it out to the actual user on the other side of this web services API? But it's specific to your application whether you want to do which one of those things that you actually want to do. But we throw, and everything gets unlocked on the way out. And again, no harm, no foul. All the data is still consistent. Hardware failure. Basically, we tried to read, and your hard drive is saying, like, no, I can't read the disk. And so we go out, throw an exception. No data has been written. Your hard drive is kind of messed up. Maybe you should have your IT team look at that. But at least we haven't written any bad data at this point. So once we move on to the next phase, and we are actually starting to write any new records, we write them and we take a lock as part of the same operation. So as the record gets written, it gets written locked. So we already have a manual lock on the records that get created. So no one can like sneak in on top of us and like change them while we're in the middle of writing these new transactions. We hold that lock. So points of failure here are I'm unable to make a record. So I've just offered a duplicate key, or the disk is full, or something like that. So what we do in response to that is, in reverse order, we go delete those records that we created. So they are still locked, so we can delete them, because no one can get in on them on top of us. So we just go delete them in reverse order, and then throw an exception once we're done with that, and nothing has been written to disk now. We're cleaned up after ourselves. Hardware failure, that's bad. We're gonna try and delete records, but if your hard drive doesn't write, there's not a whole lot of stuff that we can do with your hard drive doesn't write. But again, we'll try and undo whatever we can in reverse order, and we'll throw an exception, and you can handle it from there. So if we get a failure in update records, so again, the primary failure mode here is duplicate alternate keys, where duplicates are not allowed. That's the most likely way that you're going to have a failure here that's based on logic as opposed to someone unplugging an IDE cable. And in response, we are going to, again, delete all of the created records in reverse order and write original values to any updated records. So we keep a full copy of whatever the record is before you started operating on it, and whatever the record is when you said, these are the changes that I made. We have the original version of your data. So we just store that because we kept a lock even after the update. We just store the original data back in and delete all the created records, and we're back to exactly the way you were before we started the transaction. Hardware failure, again, we're going to try and roll back the same way that I just described, but if your hard drive doesn't write, it doesn't write. So there's not a whole lot we can do there. If we make it all the way to the delete records phase, there is actually nothing that can go wrong other than your hard drive stopped working, because we have locks on everything, and there just aren't any logical failure modes for that, other than horrible, nothing is working kind of failure modes. So again, we're going to try and roll it back. If it's like an intermediary or a indeterminate sort of I/O failure, like every couple of requests succeeds, we're going to try really hard to roll the transaction back to clean state. But if it isn't, if nothing writes, nothing writes. And the last phase is unlock records. And again, nothing can go wrong in unlock records. It either works or it didn't. And even if it didn't, you've finished the whole transaction, so all the data is actually consistent at that point. So when we read your data is records, right? And Entity Framework and .NET doesn't really understand records. They're not a fundamental concept that other people have built into the framework. So we have to materialize your record into the data object that you're using to represent that record. So that materialization is very customizable. So if the shape of your data object is non-standard for some reason, or you have custom logic that needs to get run for a particular data object, you can put it in our various partial methods that we support for data object creation to do that processing essentially in line with the rest of the stuff that we're doing. Joined objects. So if you have defined relations for your data objects, so we know that customers can have some kind of notes field. Imagine with fixed record sizes, your notes fields are not infinitely long unless you use multiple notes fields. And you say, like, is there another note field? And you've put something special in your record that says there's an extended notes field, and keep reading and keep reading and keep reading. The user who sees this EF core object, you probably don't want them to receive a whole bunch of notes fields with continuation characters at the end of each notes field. You probably want to present them with a single notes object, right? Like they should interact with one notes object, and then when you read the object, you convert it inside of the data object materialization into just the one, and when you store it, you go back the other direction and you convert it back out into a whole pile of notes fields, and those are what actually gets written out to disk. So this is where you can do that kind of customization. Inherently, as a framework, we don't understand these things, but you guys do, which is why we offer it as a customization point, because we can't guess how you want to actually implement these things, but we know that they are out there. The other thing that we do in here is we efficiently iterate the join select enumerator or the file channel read-s, read, find operations that are appropriate to be done here. So we do have to do a bit of work in order to create a plan for how we materialize your objects. But again, as with everything else in the framework, pretty much, we only do it once and we cache it and keep it around and use the same plan for each time we do stuff. And this follows best practices for unchanged result rows. Has anyone in here used join select by hand before? Yes? One of the sticky, difficult points in there is when you're iterating the collection, you have to ask, has this row changed yet? And it's difficult to keep track of manually, but we do that stuff for you, so things are as fast as they can be. Relations are an important part of your web services, and as a result, are an important part of our EF core provider. So they are understood by the Harmony core extensions for CodeGen. So we have a DLL extension to CodeGen that does all of these sorts of things for you, but that code is controlled by repository, your defined relations inside of repository, and a JSON customization file. Essentially what we found was repository was only capable of representing about 90% of the relations that exist out in the world. And we needed to make it just the extra little bit. So we punted and said, we'll just write this file and you can manually change it and customize what decisions were being made to get you the rest of the way there. And if you look inside of our generated code, you'll see these relation types, and they are actually identified in code as type A, B, C, D, and E, because it's a lot easier to have a conversation about a letter than it is to have a conversation about, is it a many to one to many, or a one to one to one, or a one to one, or a one to many to one, or a one to many? Steve and I got very tongue-tied, and so we moved to letters, and it worked out better that way. So here's those letters for, if you guys are ever curious, that's what they are. But that is the list of relation types. We don't represent many to many because I don't think that actually exists terribly much in real commercial software. It doesn't, it's just hard to think about, but that's the only one that's missing from this conceptually. But imagine in there, if you have a customer and their orders, that would be, I have one customer and I have many orders. So that's a one to many. If my orders have a customer ID on them, then that represents a backlink. So I can get from an order back to a customer. So actually, instead of a one to many, that's a one to many and then back to my one. So they only point at one. So that's what we mean with the arrows and there's many of them, or there's one of them, or there's many. The third step is always looping back around to where you started. Out of EF Core, and just a quick explanation of how URL routing works. So down at the bottom, we have our client. And our client can be anything, right? Because at the beginning of this presentation, I said accessibility is the important part of web services. So our client could be anyone, but they make some kind of call using a URL, and it makes it into us in your web server that's running in IIS or wherever it's running. And the first step along this very granular journey that I've put in diagram form is authorization. So we want to make sure that if you have turned on authorization, that the only people that are allowed into your web service are the people you want in your web service, because malicious intrusion is not good, and we don't want you to leak all of your data, because it's really great to not see yourselves as a news headline. And authorization and authentication is one of the many ways to not show up as a data leak headline. So once it makes it through authorization, because whatever the credentials were that were provided by the client are good, we move on to ASP.NET Core routing, and there's two different directions that we can go from there. One is other and question mark, which is saying essentially you can do whatever you want. Their routing is extensible. You can override whatever you want there. So if you have some custom routing behavior, you can implement it, and it is going to be standard ASP.NET Core implementation work. The other route is it can go down OData. So that's going to be the routing conventions that are provided either by us or by OData, the standard. So by default, it's going to go up to your OData controller. So we've either code generated that or you've written it by hand. But it's a class that inherits from OData controller, and it has a name on it, and the convention is determined based on the name of the class or by an attribute that's attached to the class. So that's how they decide, like, this URL maps to this particular OData controller. So it's literally the name of the class in code, or an attribute that says, here's my URL, please route if you see this URL. Those are the two ways. The other option is what we call Sprock routing. So this is, I have some arbitrary code. It doesn't really know anything about web services. I just threw an attribute on it and said, this is its name, and I registered it, and we will translate URLs based on what you've registered to go dispatch to your Sprock routed code. So it's just arbitrary code that is your code, and it takes regular parameters, and we decode what's being passed in from the user into your parameters. So it's actually a lot like the OData controller stuff. There's just less effort on your part for translating passed-in parameters. That's really the main difference, and it's not actually web-specific code that's being expected to be on the inside of that. The third way is adapters. So if OData controllers, generally speaking, understand complex filtering operations and things that you can do on your data, adapters are a halfway bridge to that. So your code probably has things in it for doing like search operations. The example that prompted this implementation was searching for room availability. So there's a set of criteria that you provide in code, and generally speaking, it's just a set of parameters, and some of them are optional parameters, and you guys know how you implement search in your environments. And we wanted to translate OData queries into old-style Synergy search routines. So that's essentially what we did. Rather than being parameters, we just put what would have been parameters and optional parameters as fields inside of a class. And we put attributes on them to say, like, this is how you're supposed to translate this. This is a match criteria or a less than criteria or a range criteria. And you just tag the fields, and we will translate the complicated OData thing into the data structure that you were essentially already taking today in your code that doesn't know anything about OData. So all of these little boxes are talked about also in our wiki in pretty detailed depth, because I'm not giving you guys any examples, but we do give examples in the wiki. So if you want to dig in farther to the specific items here, the wiki on the Harmony Core GitHub digs into these very, very, very deep. So next on our web services journey through routing is your code. Might be generated. That code is either going to go out to Entity Framework, EF Core, either your logic directly running in .NET, or traditional bridge. I'll go into traditional bridge a bit later, but we're going to get an answer, and it's going to get serialized and filtered by OData, sent out back through ASP.NET Core and HTTPS, and then handed to your client. So that's the life cycle. Request comes in, routes around, hits your code, serialized, back out to the user. So that's just an explanation of what I just went through. So one of the parts that I talked about earlier was code isolation. So if you want to run in process, globals and commons and statics are dangerous because they're globals and commons and statics, right? Like if I have two requests come in and they both write to a global, bad stuff happens because which one wins? So they cause problems with multiple threads, and this web server environment that we're talking about is very multi-threaded, so they cause lots of problems. We isolate them in a couple of different ways. So in .NET Core, we isolate them using a thing called an assembly load context. It's like an app domain, but it is a lot faster. Like, it is basically the same speed as not having an assembly load context, which is very different from app domains. App domains were like a light process in terms of cost. Like, they cost less than a whole process, but they definitely had a cost associated with them. Assembly load contexts are very cheap, but they are .NET Core only. So they're a new thing that Microsoft is offering. The only thing that they don't deal with that most of you will potentially run into is fixed channel numbers. So if you use channel 5 every time you open your customer's file, rather than dynamically allocating channel numbers, this does not help you. So you'll end up either needing to be outside of the process or in an app domain. But in general, please don't do this. If you're writing some new code, don't use fixed channels, please. Our other option is we can run it in a separate process. So we're running on the same machine, but we're going to run it in a separate process. So we'll spin up a process and connect to its standard in, standard out. So basically its terminal. And then we will talk to it using JSON RPC 2.0, which is a standard for doing remote procedure calls using JSON as our encoding for it. This works with traditional Synergy. It can work with Synergy.net as well if someone wants it to. And interestingly, it can be made to work with other languages. So this is one of the sort of unexpected bullet points that we've gotten a lot of interest in from other people who have other legacy environments. So if you're supporting 3 different legacy environments and you want to have one answer for web services, this actually ends up being surprisingly attractive because most languages can read and write JSON and can read and write terminal I/O. And those are the only 2 requirements for supporting this. So if you have some RPG thing that you have to run in the back end, like you can read and write JSON and you can support this protocol and it's pretty straightforward. Or if you have some other programming language, COBOL or Power Builder, you can build in support for this and it's not a very big part. And CodeGen can help because CodeGen doesn't care what language it's producing. CodeGen only cares about the data structures that it's been handed and the templates that you're instructing it with. So that's running it in a separate process. We can do the same thing, except we can run it on a separate machine somewhere else. So if your web server is Windows and your data lives on VMS, for example, we can do the same job, but we SSH to your VMS machine or your Unix or your Linux, and we spawn a process, connect to its standard in, standard out, and we do the same thing that we would have done, except over SSH. So it's nice and encrypted, well understood by IT managers, uses standard ports, and compression, right? Like it's not run length compression, like where you only encode the zeros. It's like real mathematical compression, and it works pretty well, and it's very fast. So why not XF Server Plus? XF Server Plus is a proprietary protocol. It's been around for a while. Pooling is simultaneously very necessary and can be difficult to implement. IT admins don't like stuff they don't understand. When you walk up to an IT admin and you're like, hey, I need to get the ports open for XF Server Plus, like if you haven't previously had that conversation with them, they're going to look at you really funny and be like, what is that? That sounds... I don't want to do that. If you walk up to them and say, I would like to open up SSH, they're probably going to say, okay, yeah, we need to deal with which users are going to be allowed to do that login. But from a network perspective, they understand how that thing works and they understand the constraints and they understand what questions that they need to ask you in order to like efficiently deliver that to you. So security, it's normal login and user privileges. Yes, we are enhancing XF Server Plus to no longer need root, but inherently this thing doesn't ever need root. It just runs as whatever user privilege you connected with. You connected over SSH with a user, and that's the context that we run in. So you're in control of all of the privileges, and you can have your IT admins lock down those privileges to prevent people from doing stuff they shouldn't. It is encrypted from start to finish by default. You can't not encrypt SSH. It's not Telnet. The S at the front of SSH is secure, so it is always encrypted. And it's encrypted with industry standard stuff. And data compression is turned on, which is also great and not really present in XF Server Plus. But what do you do if you already have XF Server Plus? It's going to keep working. So if it works for you, you can keep using it. It's not going anywhere. We're not deprioritizing it or dropping support for it or anything like that. So if you're happy with XF Server Plus, keep your XF Server Plus running. If you want to move, CodeGen now understands method catalogs, and we can generate wrappers for your XF Server Plus to use this instead. So we're not done with 100% support here. We have some initial support for generating these wrappers, but it is the current highest priority ongoing project that we are working on in Harmony Core is to support all of the different data conversions and coercions and various different parameter types and encodings and stuff like that. Just a quick bit about authentication and authorization. We use ASP.NET Identity for all of our authorization stuff. That is super customizable. Anyone can write an identity provider. There are lots of them out there. And it supports all sorts of different persistence mechanisms like ADFS, so your Active Directory stuff can get used. Azure Active Directory if you're doing the same thing but in the cloud. OAuth, I have a typo there. It should say OAuth, not OData. It's a role-based provider that supports custom access control. So your users basically are defined as like they have this role or that role or whatever, and they get marked with it, and that's how their security gets controlled. They are claims-based and unit testable. So testing is still an important part of this, and being able to say like, would this request succeed or not is handy. So the identity provider exists on its own, and you can test it from the outside and determine whether someone should be able to do something or not. Most of the time, if not all of the time, this stuff is controlled using a JSON web token. So it's passed in as an HTTP header, and you're essentially saying like, here's my authentication credentials. And it's this encrypted blob of stuff that's opaque to anyone who doesn't have the keys to it. But if you do have the private keys to it, you decrypt that blob of stuff, and it identifies here are the roles that this user is good for. So you don't have to go hit a database, which is a potentially expensive call, in order to determine what this user's credentials are and which roles they should be allowed to perform actions with. And so skipping that database round trip for security is a big, big part of how you make web requests work in that 1,000+ concurrent connections kind of environment. And the cryptography is what keeps us safe there and allows us to not worry about them handing us some forged token that includes more privileges than it's supposed to, because they can't. It doesn't work that way. We offer authentication at the controller or operation level. So you can say like, they have to be authenticated, period. I don't care what role they are, but they have to be logged in order to get access to this controller or this particular operation. And then there's role-based authorization. So you're going to specify like a comma delimited list of here are all the roles that can operate on this thing. And then it gets validated. And there's also role-based authorization at the field level. So in repository, you can go tag fields and say like, this needs to be authorized. Like if you're not signed in as a user that has this role, when you ask for this structure's endpoint, we are not going to give you back this field, that field, and this field because you don't have permissions to see the social security number for this customer. You're not that kind of user. So even if you ask for it, we will not give it to you. So that's field level authorization. Multi-tenancy is the idea that I have a whole bunch of different customers, different sites, potentially a commingling of ISAM files or completely separate ISAM files. But there's an identifier somewhere that says, I'm customer A, I'm customer B, and right now, today, you probably have some file that you go and look up and read, probably like a relative file or something like that. Customer A's relative file says, if I want to look up customers, this is the file name for that. If I want to look up items, this is the file name for that. And it's specific to customer A, B, C, and D. So multi-tenancy, we have pretty straightforward support for it now. You just declare, yeah, I want to use multi-tenancy. And you give us an implementation. We have a sample implementation that you can use if you want. And then you register a file channel manager that when someone asks for the customer's file, you are given their tenant ID, so customer A, and the file name, and we ask you, please kindly, will you translate this file name into customer A's version of this file name? So whatever operation you would have done today in your logic to do that translation, please do that here, but do it inside of our framework of stuff so that we can take advantage of your logic knowing what to do. So that's basically just a override file channel manager class override the Git channel, put your code in to do the translation, and we offer up what the tenant ID is as a static property. So relatively straightforward. We do have an example for it in the GitHub repository, and there is very detailed instructions on the wiki for this as well. So where have we been successful so far? What's the scenario? I tend to think of the main one as RESTful ODBC++. So it's a lot like ODBC. You're offering read access with queries and selects and all of those sorts of things, but it offers a bunch of other things as well. It's not really ODBC. It's easy to think about it that way. We end up putting guardrails on the ways a client can query to prevent operations that might take hours to complete. That was kind of one of the big problems with offering out an ODBC endpoint, that people can just like ask it anything and it might take 3 weeks to get an answer, and that's really bad for the health of your servers. You might only offer read-only access, but only some users are supposed to have access to various bits of that data. And so we offer a lot of security configurability around who can get access to those parts of read-only data. And the other big difference is HTTPS instead of raw TCP/IP. So offering ODBC over the internet is a very questionable proposition that you might not want to do. Everything gets in the way if you try and do that, but HTTPS, the internet loves HTTPS. Everything runs on HTTPS, so that makes offering that out as a web service a lot simpler. And external consumers that have absolutely nothing to do with us or you like having standards. So there are a lot of external consumers that just understand OData inherently. So we support OData, they support OData, they work together, it's great, everyone's happy. The other place that we've been successful so far is doing custom code with assembly load context isolation. So this particular customer didn't really have a whole lot of use thus far for exposing data directly. They just wanted to expose custom logic, but it needed to be isolated and handed out to the outside world as an OData service. So that's what we did, and it's been successful. Those are not the only scenarios. These are just the examples of things that we've done really well so far. If you want more information, the GitHub repository at Synergex Harmony Core is where all of the source is. It's where issues can get logged. So if you have something that goes wrong and you don't feel like emailing me directly, or support@synergex.com, you can create issues on Harmony Core there, and we can have a conversation about whatever it is and work towards solving it. That's also good for not just bug reports, but for like, I would like this feature to exist, please, and describe that feature and create an issue on GitHub, and then we can everyone else can sort of collaborate on it at the same time. The wiki is there. There's a lot of information on the wiki. We also have a development blog at synergex.github.io/harmonycore. Up there right now is the product plan that talks about what our main priorities are, approximate timing for when those things will be done, and what we've been doing since the conference, essentially. So we will keep adding more posts to that as time goes on. And synergex.com/web-services has links to resources. That's the web services side of solutions. And we also have video playlists that are Harmony Core specific if you want to see all of our conference content. And I think there's some internal video recordings as well that have been collected that are specifically about Harmony Core. We have 3 upcoming dates for office hours with Harmony Core. So those are basically webinars that if you connect to them, I'll be there and I will maybe give a little bit of presentation, but it's mostly about you have questions that I can hopefully answer. So these are vaguely specific to Harmony Core, but I'm probably going to answer whatever anyone asks. So those 3 dates on there are when those are, and that's it for me.